Hello everyone. I'm Yashashvi Tiwari. Welcomes you all in today's session. Thank you for joining your today's session. This session will focus on three AWS services: Cloudfront, Global Accelerator, and data migration. We will have Faisal Khan as our guest speaker to over this session. He is AWS Hyderabad User Group Leader, founder and CEO at ecom.in. Before I hand it over to Faisal, would like to request all folk who haven't still registered will please do it today with the link of registration form in the description of the video. Post the registration, we will provide access to the chat group and share material via it. So please register it. Now I will pass on the control Faisal. Thank you Faisal for joining us today. The stage is yours. Thank you.
Thank you so much, Yashasvi, and thank you for that wonderful introduction. And okay, so wonderful to see everyone join into the session today. Let me just make my screen bigger. Yep. Okay. All right. Wonderful to see a lot of you joining into the session today. And we do have quite a packed session. I hope most of you who are joining in today also attended our previous sessions because a lot of what we are doing today is also kind of related to that as well. So let's get started with a quick introduction about myself. This is me. My name is Faisal Khan. What I currently do is I am currently founder and CEO at two organizations. One is Ecom India Cloud IT, which is India-based, and we are actually an AWS partner. So we help organizations move on to the AWS cloud. Also, founder and CEO at Excite Logic, which is a US-based company. We're currently in a startup stealth mode. We're building out a SaaS app. So hopefully you'll see that come out soon as well. On the AWS side, I am currently the user group leader for AWS user group Hyderabad area. And also I happen to be an AWS community builder. Well, part of that responsibility is also doing sessions like this in order to help more people learn about AWS. And also I am an AWS certified associate. What else do I do? Well, during my free time or otherwise, when I'm not working on my company, I also run a YouTube channel as well as a training channel known as EICIT Learning, which is more or less related to Ecom India, but it's more or less AWS training based. So do have a look at it when you find the time. Also, recently, I started out my own brand of merchandise known as Racer Parrot. So this is something related to Formula One. So if you have been following Formula One and you would like to buy some merchandise, do have a look at the website, or even it's actually there on Amazon if you want to buy anything. Okay, with that, let's look at today's topics that we're going to cover. So we're going to cover three main topics today, which is Cloudfront, Global Accelerator, and DMS or Database Migration Service. Now, Cloudfront and Global Accelerator is part of the content delivery services that are there for AWS. And last week, we actually covered networking, right? So there is a lot of interrelation with networking here. So hopefully you remember most of what we covered last time. But let's get started with Cloudfront. So we've already seen that AWS has many regions worldwide, right? And this number keeps changing quite a bit. I will have to check if this is actually updated because every few months you have a new region coming up every few months. But that all of these different regions exist for AWS where you could go ahead and start your services. As an example, let's say you have your setup, you went ahead and set up your servers somewhere in North Virginia. So you have your application running there and you're trying to serve a global audience. So anybody within the US, they can actually reach your application much faster, right? But what about people from other regions? For example, there are customers that you have in India or customers that you have in Europe. When they try to access, they have to come across the globe through all of the networking cables that have laid across the sea and come across, and they have to connect into your environment. Now, this obviously is going to make everything slower. It's going to increase your latency, etc., etc. Right? So there is obviously another choice that you have, which is instead of having to, just run one region, you can choose to run multiple regions. So you can choose to have your environment in North Virginia. You can also choose to have a copy of it maybe in Mumbai. So now people who are closer to Mumbai, like people who are closer within that vicinity, will get redirected to, this region by making use of Cloudfront. If you by making use of Route 53. So if you remember last week, we actually talked about geolocation routing within Route 53, where you can send people from a certain region to a particular setup that you have already set up, right? So people who are in the North America region, they will all connect to the North Virginia setup, and people who are in the Asia region will go ahead and connect to your region in Mumbai. But this can soon start getting complicated. It can get expensive because it's not just two regions. You have many regions. You might want to open up a new region in Sydney. You might want to open up a new region in London, because you want to provide lower latency to your users and your customers. Well, if you keep doing this is obviously going to start replicating your environment multiple times, and it's going to start getting expensive. So what is the alternative that you have? Well, it's not exactly an alternative, but it's going to actually help you a long way in trying to reduce the latency if you have only maybe one or two regions that you're setting up. This is where the concept of edge locations come in. So as you can see, there's a lot more dots on the map here compared to your regions, right? So compared to your regions, there's a lot more locations that you have known as edge locations. So what are these edge locations? Well, edge locations are places where AWS actually has some servers that are specifically used for caching your data. Okay. Now, these are not places where AWS has a full-fledged data center. It could just be maybe in a city, they have one floor in a building that has a lot of connectivity. So there might be servers that are fully stacked in that floor in that building, and those servers are specifically used for caching your data. Now, when I mean caching, let's assume the previous example that you have set up something in North Virginia. Okay. Well, there are a lot of edge locations in North America, but also across the globe. But let's assume for a second that you've set up your environment in North Virginia. Now, all of these edge locations, they're actually connected through AWS's backbone, which is AWS has their own fiber channels, or you can call them network cables that they have actually laid across the globe, right? So they have, cables that are running across the globe underneath the sea, just like any other telecom provider. So all of these edge locations are actually interconnected with the AWS backbone. What that means is, if you actually get into one of these edge locations, so if you actually connect to one of these edge locations, you're basically connecting into AWS's network, and then you get the fastest access to all of the regions that AWS has. If you would normally connect to AWS, let's say that if you would normally connect to North Virginia without using an edge location, you will basically be redirected through all of the different telecom providers that use all of the different cables that lay across the globe, and it'll get you connected there. But there could be a lot of additional latency because it's not a dedicated network. That is basically the internet that you're using. But if you happen to use an edge location, the difference here is that the edge location is connected with AWS's own backbone, which means you get extremely high speed because it is dedicated for AWS users and AWS consumers. So the idea here is that instead of having multiple locations, so instead of having North Virginia, instead of having London, instead of having India, instead of having Australia, let's assume that you have two regions that you're running, right? So let's say you have a region in Mumbai and then you have a region in North Virginia that you've set up. Now, what happens is, let's say someone from Europe is trying to connect to your application. then instead of they having to come over the internet and then connect to your region, instead of that, now they can get connected directly to one of the edge locations. And from that edge location, they can get quick access to one of the regions that AWS has, because it's AWS's own network. So this is basically going to increase the speed of transfer of all of the files, all of the data that you have, and it's just going to reduce the latency for your customers. So this is not a new technology. This has existed for quite a long time. This is basically known as a CDN, or a content delivery network. Akamai is another company that has, a CDN that has been in existence for several years, even before Cloudfront actually came in. But Cloudfront is essentially a content delivery network, which means it actually helps you connect. It actually helps you connect faster to an edge location, which in turn helps you reach the destination much more faster. But Cloudfront does have some additional capabilities. So apart from these edge locations helping you connect into AWS much faster, what happens here is anytime someone accesses something via an edge location, okay? So let's say in the Mumbai region and in North Virginia region, you have a file called abc.txt. Okay, you have a file. This is a file that you have on your application. And let's say people are trying to access this file, right? So let's say someone in Norway, or someone in the north of Europe actually connected to this edge location over here. And let's say they got connected to your server and they downloaded this file called abc.txt. Okay. Now that file, through the CloudFront edge locations, actually gets cached at one of those edge locations, right? So that if there is a second user or a third user who's connecting to that same edge location and requesting for the same file, that request does not have to come all the way through to your actual region. That file will get directly downloaded at the edge location itself, because it gets cached there, so people can consumers or your users can get direct access to that file from the edge location itself. But do remember, it is a cache copy. It's not the actual file, as in, yes, it is the file, but it's a cached version of that file. We'll talk about how the cache handling works and how often the cache gets refreshed and all of that. But essentially, these edge locations, along with the combination of CloudFront, increases the speed of access of your files, reduces the latency, and also ensures that the files are cached at the edge location, so that users don't have to wait for the connection to come all the way to your actual region where you actually have your applications in order to download the files. This actually saves you cost. You might think, okay, I'm setting up an additional layer and it's going to cost me all of this money in terms of transferring bandwidth and caching and all of that, but this actually saves you a lot of money, and we will talk about how that actually works. I'd like to stop here for a quick second and ask if anybody has any questions so far. If you do, please post your questions in the chat. And for those of you who have questions after the session and watching this in a recorded view, please post your questions in the comment section and we can help you out. Is there a cost benefit for connecting to the edge location? Good question. This is what I was just about to tell you. Yes, there is cost advantages. I mean, if I were to put it in a simple way, I would say that the cost that you pay for AWS is dependent on, let's say, how many EC2s that you're running, right? So obviously, if you run 50 EC2s, it'll cost you XYZ amount. Okay. If you run maybe 25 EC2s, it'll maybe cost you XY amount. And maybe if you run only 10 EC2s, it'll cost you X amount, right? So as an example, right? So what happens is, the reason you're having to run a lot of servers is because you're having to serve a lot of requests that are hitting your servers, right? But by making use of the edge locations and by making use of CloudFront, you're actually serving those requests at the edge itself, and those requests never actually hit your original origin, which is your EC2. So by that sense, you can actually end up reducing the number of EC2s that you have in your environment, because there are lesser number of requests that are actually reaching your server, because it is being served at the edge itself. Now we'll talk how that works in terms of how the file gets delivered and how it's cached and how you can cut down on your cost and all of that. But essentially, this is the idea when I talked about saving cost, right? You can reduce your cost by reducing the number of servers that are basically serving your content. Is all Another question is, are all regions supporting edge location? Um, Well, edge locations are not just region dependent. So you will almost always find an edge location in a region, but you will also find edge locations where regions don't exist. As you can see an example over here, in Africa, you have several edge locations, but there is no regions in Africa, right? Especially also in South America, you can see there are many additional edge locations, but there is only one region in South America. So you will always find edge locations both in a region as well as outside a region. Whether we want to, there's another question from Dora Chaudhary, and that is whether we want to select edge locations based on your demand or AWS itself creates. Okay, so I will answer this question when we actually configure the CloudFront distribution, because you do get the option to select the type of edge locations you want to use. I mean, you don't get to pick and choose exact edge locations, but there is a little bit of choice that you can make. So I'll cover that when we actually get to the labs and show you that. Rohit has another question. This question is more, yeah, I think that's a question for later. Is it wise to use the edge location even if I am okay with latency? I'm not sure if I fully understood the intention behind that question, Adarsh. Maybe if you could elaborate on that question a little bit, maybe that will help. Okay, Rohit has a question on origin access identity. Okay, we'll get to that question, Rohit, once I explain how the actual caching works. So CloudFront is essentially a content delivery network that helps you deliver content with low latency, high transfer speeds, and there is no commitment. Like, you don't have to prepay anything. It's completely pay as you go, depending on how much is being used. There are several edge locations. Okay, I do need to update this slide because right now it's over 310 plus points of presence. So it's not 185 plus. It's about more than 300. CloudFront does integrate with a few services on AWS, and we'll see what those are. You can also serve both static and dynamic content, which we will discuss a little bit later on. And you do have some additional, advanced features as well, like, for example, restricting the type of content that you deliver. For example, you want to deliver private content. Let's say you're running a training website and you need to provide the training videos to your students, but then to your trainees, but then you don't want anyone else to take those videos. You can actually make them private and ensure that it only gets delivered to the actual people who are authorized. So it's not like anybody can download everything that you put on CloudFront. There you can put restrictions on. So we will actually see what those are. Okay, just to explain the whole concept of how this caching mechanism works, you of course have your origin. Your origin basically is your original location where you actually have your files and where you actually have your data or your actual servers. Now, there are different types of origin that CloudFront supports. You can have your data in S3 buckets. You can have your data behind ELBs. Now, obviously, this is not fetching the data from ELB. Behind your ELB, you will obviously have multiple EC2 instances, right? So if you want to connect your EC2s, you essentially need to run that through an ELB in order to make use of CloudFront. And of course, there are a few other services from AWS that is related to delivering media, which is like either live media or recorded media. There are other services that you can use. Today, we are going to stick with S3. We're going to see how you can use CloudFront with S3 in order to actually deliver the content. Okay, so origin is where you store your original files. That's where your files are starting, right? And then, of course, you have the edge locations. All these edge locations are the one that I just showed you on the map, all of these blue-colored edge locations. There are some purple over here, which is basically multiple edge locations, and there is regional edge caches, which I will talk about. So let's assume that these are just your general edge locations. And like I said, these edge locations are not full-fledged data centers. So for example, if there is an edge location there is actually only one region in India as of today, which is in Mumbai. There is one coming up this year in Hyderabad. I'm excited and looking forward to that. But in India, at the moment, there is only one region. But there are several other edge locations. For example, there is an edge location in Bangalore. There's an edge location in Hyderabad. So there are multiple edge locations. So those edge locations are not full-fledged data centers. Okay, like you can't launch EC2s in an edge location. An edge location is specifically used only for caching as part of your CloudFront distribution. So just keep that in mind. Now, let's take that example of a file, abc.txt. Okay, this can be anything. This can be an image, this can be a video, or whatever. Now, you have this file stored in your S3 bucket. Like I said, we are going to stick to S3 bucket for this. So let's say you have this file stored in your S3 bucket. Now, normally, if you are not using edge location and you have all of your different users that are coming and trying to access this file, they will essentially access your S3 bucket, right? They will access your S3 bucket URL directly and they'll try to download that file. But obviously, the problem here is that every time someone needs that file, they have to again come to your S3, hit S3, and read from S3. Now remember, for S3, you are charged based on how many reads are happening, like how many operations are happening for get, put, etc. So if you have like millions of requests, you will be charged accordingly, right? So the idea is to reduce the number of requests that are actually hitting your S3 bucket. You will obviously also be charged for the data transfer, right? So if it was, let's say, a movie file, a video file, right, a .mpg or a .mp4 file, and that is maybe 1 GB, and if 10 people are downloading it, essentially you have to pay for that 10 GB directly from S3. And obviously if you're using something like infrequent access or something, you will again get charged more because you're using up that data. Having said that, the idea here is to reduce the number of hits that are happening on your S3 bucket. So what we're going to do here is we are going to actually connect these edge locations to our S3 bucket. And once we do that, all of these users, let's assume that all those 3 users that we just mentioned, they are all in and around a single edge location, right? Let's assume that they're all in and around a single edge location. So if there is one user that requests abc.txt, what happens is when the request hits the edge location will first check, is this file actually present at the edge location or not, right? If it's not present at the edge location, it will then go all the way to the S3 bucket. It will fetch that file, it will bring it back to the edge location, and it will actually save that file as a cache. It will save that file on the edge location and then give that file to the user. Okay, so this is the first time the file was requested. The request hits the edge location. It will check if it's there in the edge location. If it's not there, it goes all the way to the origin. It fetches the file, brings it back, puts it in the edge location, and then delivers the file to the user. The advantage over here is that the next time someone requests that same file, that request does not have to go all the way to S3 because that file is already present at the edge location. So the user will get delivered that cached version. Okay. Now, obviously, this is going to depend on how many edge locations you're using and where those users are. Because as an example, if there is one user that requested that same file, abc.txt, it was not there, it went and fetched it from S3, brought it back and saved it here, right? But then let's say there is another user somewhere else from some other edge location that is hitting for the same file, abc.txt. Now it was copied to this edge location, but it was not copied to this edge location, right? So it's not there. So it still has to go back to the origin. It has to fetch that file, again, bring it here, save it here, and then give it to the user. But obviously, anytime someone else hits the same edge location, they'll get the file from the edge location itself rather than having to go to the origin. So this way, I would say that, let's say you had maybe 10,000 hits per day on your S3 bucket. I would say that the number of hits ideally would be reduced to maybe like 2,000 to 3,000 requests, right? Because you have those requests that are spread across edge location. Once an edge location makes a hit, it doesn't request for that file again, unless, of course, the cache expires. But till the cache expires, it's not going to request for that same file again. So you have lesser number of requests that are now hitting your bucket. So you pay lesser for the number of requests and obviously lesser bandwidth because you're not taking that data out from S3. So I'd like to stop here and ask if you have any questions. Say I have, okay, Adarsh has a question. Say I have one server hosting my app and I want to use only one server to serve the world. If I use CloudFront, would it cost me extra? Well, this is a very tricky question. So it's a very specific one. You're asking if you have one server in one region and you want to use CloudFront, is it going to save you money? Well, I would tell you that it would save you money in one area, that is in terms of bandwidth, because remember, bandwidth out of AWS is not cheap. I'm not saying it's expensive, but it's not cheap either. So anytime you transfer data out from your EC2 onto the world, there is an X amount of charge per gigabyte, right? But when it comes to CloudFront, you actually get 1 terabyte of transfer free. I mean, before it was only 10 gigabyte, but they recently upped that quarter. So anytime you transfer data out from CloudFront, you get 1 terabyte of outbound transfer free, right? So this now actually reduces your transfer cost. And in fact, to answer your question very specifically, yes, because like I said, I do run a training program website as well, which is actually running on a single server, and it actually cut my cost by approximately 50%. Because I'm no longer serving that content directly from my EC2, but I'm serving it through CloudFront, and the videos that are going out through CloudFront, it's much lesser expensive because the bandwidth is less expensive. Okay, so I hope this part is clear. Okay, so what is the challenge here, guys? What do you think the challenge here is going to be? Because when initially, the CloudFront locations started out, maybe you had like 10 CloudFront locations or 20 CloudFront locations. So instead of 100 requests hitting your S3 bucket, maybe now that has gone down to 10 or 20 requests, right? But the problem started when the number of edge locations also started increasing. So you had now 200, 250 edge locations across the globe. So what happens now is every edge location starts making the request for the same file, because there are people that are coming from different edge locations, right? So initially, if the number of requests went down, as the number of edge locations started increasing, this number of requests also went up, because now you have more edge locations hitting your origin, right? So this maybe went from 2 to 3K to maybe like 5 to 6K, because the number of edge locations increased. So what do you think is a solution here? What would we do in order to reduce the number of hits while we still kind of want to still use edge locations, but we want to reduce the number of hits that are hitting our origin because the number of edge locations has increased? Any suggestions? What could we possibly do here? Yogesh had a quick question about Media Store and Media Package. Those are different services that are not kind of part of CloudFront. So maybe another session, but it's not also it's not core part of your solutions architect associate, because those are like additional media services. So don't worry about that at the moment. But those are services which are used for delivering content on AWS. But you're not going to see that come up in SAA exam mostly. All right. The solution here is pretty simple. You introduce another layer of caching, which is known as regional edge cache, right? So these regional edge caches are kind of like the main caches, like the main edge locations sitting within a region, right? I wouldn't say that it is within a region, but that's the idea. They want to put those edge location within a region, right? So now all of those edge locations that are kind of nearby a region will get connected to the regional edge cache, and then the regional edge cache gets connected to S3 or your origin. So let's kind of look at that request again, abc.txt. So this goes and hits your edge location. The file is not there at the edge location. It goes and asks the regional edge cache. The file is not there at the regional edge cache. It will go to the S3 bucket. It will pull the file. It will save that file here. Okay, abc.txt is saved here. It will deliver that file to the edge location. The edge location will also save it, and then it will deliver that to the user. Now, the advantage here is that unlike before, if there is another user hitting another edge location around the same region, this edge location, even if it doesn't have the file, it will go to the regional edge cache. And now it does not have to go to S3 because the file is present in the regional edge cache. So it will download the copy from the regional edge cache, and it will again save that copy here and deliver it to the user. So you see now it's just added an additional layer of caching for you, which means the requests, now the number of requests, if it initially we were at 10,000 requests, and then that reduced to maybe like 2 to 3,000 requests because you had edge locations. But as the number of edge locations started increasing, those requests started going up, maybe like between 5 to 6,000. But now that you have the regional edge cache, it's almost come down maybe to like maybe only up to 1,000 requests, like 0 to 1,000 requests. Again, these are all hypothetical numbers, but this is kind of ideally what you should be seeing, because you are now having multiple edge locations only talking to the regional edge cache, and it is only the regional edge cache that is talking to the origin. So there are not as many hits happening to S3 because the regional edge cache is now serving multiple edge locations. Okay. Now, can we improve this, or can we make this any better? Or do you think this is it? Because what happens if the number of regional edge caches increase? What happens then, right? Okay, there is another question from Shashidhar. What if abc.txt, which serve edge location, went down? I am not sure if I caught that question fully. Shashidhar, could you rephrase that maybe? Okay, Shashidhar, do rephrase that. I'm not sure if I fully understood that question. Okay, Dora has a question. What if regional edge cache fails to serve? Good question. So these services, like the edge locations, like this is not a single unit, right? Like this is not like a single server or anything like that. These are like redundant servers. So just like how you have with Route 53, which is 100% redundant service, the edge locations are also pretty redundant. I don't think it's 100%, but they're all pretty redundant. So you would it's unlikely that you will see this going down. But having said that, we have of course seen entire regions going down, so it is still possible that this will go down. In that case is where you have to have your own strategy for failovers, right? And we'll actually talk about that when we talk about global accelerator, because that helps you actually make use of multiple regions and also have a failover, kind of a disaster recovery plan as well. So not just this, any service from AWS, no matter how much AWS promises you that it's going to be up and running, you still need to plan for failure. You still need to build your services accordingly. So if this fails, you need to have another DR plan that works, right? But like I said, this is unlikely to fail in most cases. Global accelerator is not yet covered, so we'll cover that. Humber, what in case the resource served with Cloudfront before cache refresh, there is a difference in the resource? Yeah, we'll actually come to that, Ramakrishna, because I want to show you the flow of how the caching happens. Like, how does it decide when to cache and when to refresh and all of that, right? So we will talk about that. Okay. Now, this worked pretty well, but people still wanted more. So the latest update, which as of I think May or June last year, they got in something called Origin Shield. Okay, so if you see here, the difference here is that now there is something between the regional edge caches and your origin. So essentially, the Origin Shield is acting like a duplicate origin for you. Okay, and it's kind of protecting your origin from the requests. That's essentially what an Origin Shield is. It is shielding your origin, but it's kind of another origin. What that means is that all of the cache requests from all of the edge locations will be served by the Origin Shield. There is only one request for, like, for example, abc.txt. It'll only be requested once. Again, I just want to make one thing clear here. Origin Shield is an optional service. Okay, it's not like inbuilt into CloudFront. It's an optional service. If you want, you can use it because it costs you additional money. It's not necessary that you have to use it. But if you do use it, and if you have to serve the file abc.txt, you only have to hit your bucket once. That's it. All of the edge locations across the globe will have a cache of that going forward. Of course, they have to request it, but then anytime they request it, it will only come up to the origin shield, because the origin shield already took that file from the S3 bucket, so it doesn't have to ask the S3 the same question again. All right. So origin shield is a newer option. If you want to use it, you could, but then otherwise you could just go with your regional edge caches, right? So it would look something like this if you would have multiple edge locations across multiple regions that you're using. You will have your actual edge locations at the end where users are actually hitting the edge locations, okay, and they all connect to a regional edge cache, and then the regional edge cache connects to your origin. Now obviously, if you want, you can additionally have the origin shield, which sits in between your origin and the regional edge caches, kind of ensures that you reduce the number of hits on your origin. But again, it's a chargeable service, so just keep that in mind. You are adding additional cost if you do use origin shield, but then again, you are barely going to get any requests that are going to hit your origin. You can have like maybe one or two EC2s to serve the entire globe, because it's not hitting again and again. Okay, one thing that I do want to mention here is the ability for you to actually run functions, Lambda functions at the edge. So you might have heard about this concept called a Lambda at edge. So essentially what's happening here is you have the ability to now have Lambda functions actually run at the edge locations, okay, on the regional edge cache or at the edge locations, where you can use it for certain type of requests. Maybe you want to ensure that you are adding additional parameters to a URL request, okay. Maybe you want to do some kind of checks when the requests are coming in. Maybe you want to rewrite a URL. Maybe people are requesting for HTTP URLs and you want to maybe rewrite that to an HTTPS URL or whatever. So there are certain things you can do with a Lambda function at the edge even before it hits your origin. Because let's say if you want to do this at your origin, let's say a user is requesting HTTP, that request might come all the way to your origin, and behind your ELB is obviously your EC2 instances, and your EC2 instances end up doing this job, right? So you want to reduce the load on your EC2 instances. So it's better you actually make use of Lambda at edge and actually run these Lambda functions at the edge location itself, if you wish to. Any questions before we move forward? Sashidhar has a question. AWS uses SSDs or PAM cards for caching. Good question. The answer is that AWS never really reveals their exact infrastructure. They will tell you a little bit about their control plane. They will tell you a little bit about how things work on the back end, but they will never reveal exactly what type of disks they use or what type of actual hardware they use. Okay, unless they are innovating something like, for example, the hypervisors, the Nitro hypervisors, they will tell you what they are doing with that, but not your general storage. Yep, that is right, Mohammed. Origin Shield is a concept similar to Elasticache to improve performance. It doesn't necessarily improve performance per se. Think of it like it's there to shield your origin from too many requests. Think of it like that, right? Because it doesn't speed up or anything like that. It's still acting like an origin, but it is acting like an origin on behalf of your original origin, right? So it's acting like a secondary origin without you having to worry about the capacity or how big your origin is, or if it has the capability to serve those many requests. All right, let's move on to the request flow, and let's see how, when a request hits an edge location, how is it decided, when to cache, where to cache, how long to cache, etc. Right? So a user hits an edge location. So a user request comes in and it hits the edge location. The edge location obviously has a question. It will first check if that file is there in cache or not. Okay, so the first question is it there in the cache? Now, obviously, if it is not there in the cache, it has to go to the origin and it has to fetch the file. So if it is not there in cache, it will go all the way to the origin. It will forward that request to the origin, and the origin then responds back with a 200, which basically means it is giving the file back to the back to the edge location, right? So the edge location is requesting for that file. It gets forwarded to the origin, and when the origin responds back, that file goes into the cache, right? So first process is simple. Is it there in the cache? No, it's not there in the cache. It goes all the way to the origin. It fetches the file from the origin, and normally you would expect a 200 OK, and then that file will get cached. Now the file has been cached in our edge location, and obviously once it's cached, it will give that file to the user. Now this particular flow is called a miss, as in it's not a hit. Miss as in not a gender wise, but miss as in you missed it, right? So it is called a miss because that was not there in the cache, so it was a miss, right? It did not hit the cache, right? So it was a miss. Now the second flow, which is it there in the cache? If it is there in the cache, it'll ask that question, has that cache expired? Because if you remember last time in Route 53, we talked about the concept of TTL, or time to live, right, in our last session. So time to live basically defines how long a file should be there in the cache. Now, either you can manually define this in every file that you're serving, okay, or you can add additional TTL headers to your files, or you could also just let AWS decide the best TTL and have like an estimated TTL or whatever, right? But ideally speaking, the normal TTL that you set, if you don't set any TTL, the default one is a 1 hour TTL. All right. So it'll be there in the cache for 1 hour, or let's assume that the TTL is 1 hour. Okay. So is it there in the cache? Yes, it is there in the cache. Now, is the cache expired? Now the cache came here and the cache got stored here. Now, if the request came in within that 1 hour, because my TTL is 1 hour, which means it is supposed to be in the cache for 1 hour. So if the request came in on the 55th minute after the cache was saved, obviously it is not expired, right? So it will give that to the user. That is a hit. Okay. So is it there in the cache? Yes, it is there in the cache. Is it expired? It's not expired. The TTL is still alive, so it will give that to the user, and that's a hit. Now, obviously, the next question is if the TTL is 1 hour, okay, and there is a request that is coming in at 1 hour 5 minutes. So let's say the 65th minute. Okay. So when it comes to this stage, is it expired? Yes, it has expired because it's past the 1 hour TTL. This is where the request will be revalidated with the origin. Because remember, just because the cache has expired does not mean the file has changed. Okay, just remember this. Just because, for example, abc.txt has a TTL of 1 hour, which means it's supposed to stay in cache for 1 hour. If it's more than 1 hour, request for the file again, because there might be changes that happened on the file, right? This is the only reason you don't want to keep it in the cache for very long, because there might be changes that have happened on the file. So it revalidates with the origin, where Cloudfront basically goes and asks the origin, hey, I have this file in my cache, but I see that the cache is expired. Can you tell me if the file has been modified or not? Right? The question is, can you tell me if the file has been modified or not? If the origin responds back with a 304 not modified, where the origin says that it's not modified, go ahead and just reset the TTL for another hour and serve the same file. Okay, so the origin is saying, I haven't modified the file hasn't changed. Just reset the TTL and give it to the customer once again. So again, what happens is it gets saved in the cache. Okay, that comes back and it gets, it doesn't get saved in the cache, but it's already there in the cache. The TTL just gets refreshed for another hour. The TTL gets refreshed for another hour. Okay, and then it will be given to the user. But this time when it's given to the user, it's known as a refresh hit, because it had to go back to the origin. It had to kind of ask the origin and then give it, right? But remember, when it asks the origin, it could also be that the file has actually been modified, right? In that case, the origin will return back a new file instead of the older one. Then obviously that has to get cached again, and that's also kind of a refresh hit, right? I know this is a lot to maybe take in at one go, but any questions on this particular flow? Anyone? Okay, Ramakrishna has a question around securing the resources. Security is like it's a feature of CloudFront. You have the option of enabling certain types of security. For example, there is something called signed URLs which you can enable, which will ensure that only the people who are authorized to see it can actually see it, etc. Right? So yes, there are additional security features which you have to enable. Like it's not by default. You kind of have to enable that. So let me just quickly refresh through this once again. User is requesting it. Is it there in the cache? It's not there in the cache. It will go to the origin. It will fetch the file, save it in the cache, give it to the user, and that time it is a miss. Okay. It's there in the cache. Yes. Is it expired? No. It will give it from the cache, and that's a hit. It goes, is it there in the cache? Yes. Is it expired? Yes, it is expired. It will go revalidate with the origin. And if the file has not been modified, it will just serve the same file from the cache. It will just refresh the TTL and it will just give a refresh hit. Now it's important to remember these three, because when I'll show you the labs, I'll show you this actually in action, where it will say it's a hit or a miss in the request header. All right, let's move forward and let's set up some CloudFront distributions. All right. What I'm going to do here is I have a few buckets that I've set up. Specifically, there's a bucket called CF demo, CloudFront demo.aws-training.in. And as you can see, this bucket is in the North Virginia region, right? So if I go in there, at the moment, the bucket doesn't have anything. Now, normally, when you save something in a bucket, you can directly access the bucket. Like you can directly access the objects from the bucket, right? Of course, provided that you make the objects public. Now, what you want to do is when you enable CloudFront, right? Let me just switch back to the slides. When you do enable CloudFront and when you do enable edge locations, you want to disable the direct access to the S3 bucket. So normally if you have something in S3 and if you have made an object public or something like that, the users can directly access that object from your bucket, right? But once you enable the edge locations and once you start using CloudFront, you actually want to stop this method of people actually accessing your bucket directly, because what happens is sometimes people might have the URL with them and they'll try to access directly from your bucket. And there will be people who are also accessing from your edge locations, and the experience that they will have will be inconsistent, right? Because somebody will get it faster, somebody will get it slower, somebody might be getting a direct access. You will have issues with security, etc., maintaining that. And also if you're running any Lambda functions at the edge, it will not apply to this user because they're not coming through the edge, right? They're trying to access the file directly. So you definitely want to stop the access direct to your S3 bucket once you enable the CloudFront distribution. You have two ways you can do this. You can either do this manually when you set up the CloudFront, but you also have the option when you actually set up the CloudFront distribution for it to do that for you automatically. So here is our bucket. I will put something in this later on. At this moment, this bucket is already linked with the CloudFront distribution. But if it were not, all you have to do is you have to go to CloudFront and then you go to create distributions. And in your create distributions, you have to select the origin, right? Again, this origin can either be an Amazon S3 bucket, or it can be a load balancer, or it can be the other two that I've mentioned, the media store. At the moment, I don't have media store enabled, like they're not set up. So obviously that's why they're grayed out, but I do have a load balancer here. If I wish to, I can choose that. But at the moment we are doing the bucket, right? So all you really need to do is you just need to select the bucket origin. So that's your origin bucket where you have all your files. If you wish to, you can also specify a path, but it is not necessary. For example, within your bucket, you only want to serve /images through your CloudFront. Then you can actually mention the path here as /images, right? But if you want to serve everything in the bucket through CloudFront, then just leave this blank. It will take up the entire bucket for serving through CloudFront. Now you can have a name for this origin. So just for keeping things simple and identifiable, you can just remove this part and this will be the name of your origin. This is just for your identification, nothing else. Now, remember, I told you that you can actually restrict the access directly to your S3 bucket. That is this option. So somebody had a question before of what is origin access identity. That is exactly what this is, which is it is ensuring that only the CloudFront has access to your S3 bucket so that no one else can directly access the objects in your S3 bucket. When you create an origin access identity and apply that identity to both your bucket and the CloudFront distribution, only the CloudFront distribution can then access your S3 bucket. So you can say here under S3 bucket access, yes, use an origin access identity, which basically means the bucket can restrict access to only CloudFront. Now, if you already have one, you can select that from the list, or you can always create a new origin access identity, right? When you create a new one, you can just give it a name. I think I have quite a few over here already. For example, cfdemo.aws training. And then, like I said, you can either choose to do this manually, or you can get CloudFront to automatically do it for you, which basically means it has to update the bucket policy. Yes, you created the origin access identity, but that has to also be updated in the bucket policy, right? Who's going to do that? If you want to do that manually, you could, but then you might make some errors. So instead, just select as yes, update the bucket policy, where it will automatically create the origin access identity and it will automatically apply that on the bucket policy. Now, there are a lot of additional settings over here. Mostly that is related to customizing how you want to serve the objects, whether you want to cache some objects or not cache other objects, etc. Right? So you don't have to necessarily change all of the other options, but I'll just quickly run through them. If you want to add any custom headers when the objects get delivered to users, you can basically add a header over here. As you can see, you also have the option of origin shield if you want to enable that. Like I said, it's optional. It's not necessary as part of having CloudFront. So at the moment, I'm just going to leave it to no because it's additional charges. These are some additional connection settings, whether to timeout or not to timeout, etc. So that's fine. The default path, like I said, it's taking up the entire bucket, so I'm not going to change that. Compress objects, sure, why not? It'll save you bandwidth. HTTP, HTTPS, sure, why not? But if you want to also make sure that it is only HTTPS that is serving, you can go ahead and select HTTPS, right? But at the moment, I'm just going to leave it to both. The kind of methods that are going to be used on your bucket, think of it like this. This is getting the object along with the headers of the objects, right? If you select something like this, which is get, head, options, put, post, patch, delete, this basically means anybody using the CloudFront distribution can perform these actions on your objects inside the bucket. So don't do this unless you have very good reason to do this, because people can publicly delete your objects, right? People can publicly put objects into your buckets if you select this option. So be careful when you select this. So at the moment, I'm just going to leave it to get and head. If you have some options that you're passing along with your headers, you could select the second one. Restrict viewer access. This is where you have an additional layer of security in terms of restricting content to certain users. So remember, I mentioned the concept of something called a signed URL. Let me just pull up a quick whiteboard here. So a signed URL, as an example, let's say example.com, and let's say you have a video file, right? 123.mp4. Okay, let's say it's some content that you want to share within your team or whatever. Now, there will obviously be a CloudFront URL before this, like CloudFront, like cft.example.com or whatever. You will have a URL, and this is the video URL. Now, if you just post this as is with CloudFront without any additional security, anybody who has this link can basically download that file, right? And you definitely don't want that. So what you would tend to do is you would add additional parameters to the URL. For example, you might say, and uh, you might say, and let's say time, for how long is it valid, right? So if you say time, I'm just giving you some random examples here. You can have many parameters over here. So let's say time is expiring at what's the date today? It's 22nd 1 2022, and let's say it's expiring at 4 p.m. Okay, this is a very crude example, right? So what happens here is now you have this link, okay, and if you use this link will only work up to this particular time that is specified on the link. So you can maybe give a link that expires within the next 5 minutes to someone, and then they can download it. But then if they share that with someone else after 10-15 minutes or whenever, they can't download it, right? So this is where you're actually securing your URLs additionally using something called signed URLs. Now this is not automatically created by CloudFront. You have to have a software that generates these additional parameters in your URL. There is a certain set of documentation that you can follow as to how to create this, but essentially this is the concept of signed URLs, right? You also have the option of something called signed cookies if you wish to, which is basically this is not just using the URL, but it also makes sure that, for example, only people who are logged into the site can actually download the file, right? By making use of cookies, because sometimes signed URLs might not be the perfect solution. Cookies might help. So you can use this if you want to additionally kind of secure your CloudFront distribution. But at the moment we are not doing that, because if we do that, we have to have additional parameters set up, which we are not going to do, and we don't have a software that's going to generate those URLs right now, so I'm not doing that. Okay, so that's no. Cache settings, these are what defines as to how long something gets cached, right? So if there are some new policies that are automatically recommended for you, but if you were to go to legacy cache settings, you actually get some additional options here, whether you want to cache your headers, whether you want to cache query strings, whether you want to cache your cookies, etc., right? Sometimes you definitely don't want to cache your cookies, because, for example, let's say it's a login logout cookie to check if the user is logged in or not. Now if you cache your cookie and then the user actually logged out from your application, if he refreshes the page, it'll still use that cache cookie and it still might show him as logged in, right? So you have to kind of select what you want to cache and what you don't want to cache. You have options of whitelisting certain cookies, like you can not you can decide not to cache your login cookies, but maybe some other cookies, right? It's completely up to you. Of course, this is if you want to customize it and use that option. You can of course customize your TTL over here. You can customize what is the minimum TTL, what is the maximum TTL, and what's the default one. You can kind of choose that option if you wish to, but it's better you actually go with this one and just go with the recommended for S3 origins. This is kind of like a default set of cache logic that you want. And here is those Lambda functions that I told you about. Now remember, I told you that there are several flows that happens. For example, when the user hits the edge location, and when the edge location requests the origin, or the regional edge cache, and when the regional edge cache requests the origin, and when the origin responds back to the edge location. So there are several flows in this, right? And you can actually have a function in any one of those flows. You can have a function when it's only a user that is requesting it, right? You can have it when there is a response that is going out from the origin, right? So you can have different functions in different flows if you wish to, but of course you have to have that function created separately. We're not using those functions in our lab today. Now, here is that question that somebody asked before: can I select all of the edge locations, or can I select specific edge locations? So here is the option that you have. You actually don't have much of an option. You only have 3 options to pick from. You either use all of the edge locations, or you use only the edge locations that are there in North America and Europe. This is mostly if your customers are only in North America and Europe. And of course, there is the other option, which is use North America, Europe, Asia, Middle East, and Africa. Any guesses what is missing in this last one? What are the other areas of the globe that might be missing in this one if you don't select the first one? Anybody quickly? So the third one is North America, Europe, Asia, Middle East, and Africa. What is missing there? What is missing is the Oceania region, right? So like your Australia and all of that, that's actually missing here. So if you want to actually use all of the edge locations, first option you must select. Now, I'm not sure if we have actually covered WAF in one of the other sessions in our security session, but essentially WAF is a web access firewall. You can put a firewall in front of your front of your CloudFront distribution, right? But at the moment, I'm not selecting anything. But if you want, you can do that, but it's optional. Of course, if you want to give your CloudFront distribution a particular name, for example, abc.example.com, right? You can actually add that CNAME over here, and you can also select a certificate associated with that CNAME. Just remember that you have to create this CNAME beforehand, like abc.example.com or whatever that is. You have to create that beforehand, and then you have to select that from the list over here. As an example, I could say cfd or cfdemo.aws-training.in. Okay, and then I can select the corresponding certificate that I've already created in Certificate Manager, which is already present in the Certificate Manager, right? Okay, and okay, I'm getting like extremely late responses from everyone, almost like 2 to 3 minutes delayed. Can you all please make sure that you've actually hit the live button and you're actually live? Or I'm not sure if the latency is just for me. Just make sure you all have hit the live button, please. I can select that if need be. And if I have a default file like index.html or something like that, like I have a default root file, I can actually mention that over here. And if I want to enable logging, if I want IPv6, I can turn that on. And then finally, I can create the distribution. Now, when you create this distribution, it's going to take a good half an hour. If especially if you have selected all the edge locations, it's going to take a good half an hour for you to actually have all of this activated. So just keep that in mind. So in order to avoid that delay, I've already created this distribution. So if I go to the distribution list, I can see here that I already have this distribution called cfdemo.aws-training.in. Now, just keep in mind, I have given this as an additional CNAME, right? It's not necessary because CloudFront will always give you a URL or give you a domain name, right? You can actually use this URL, and it would in fact hit your bucket, right? Hit your origin bucket, right? You don't need to use a domain name, but of course you can make it look good by using your own domain name, which makes sure that it's actually hitting the right origin. So as you can see here, the origin is my S3 bucket and the status is enabled. I do have a few additional CloudFront distributions over here, but at the moment, this is what we are only concerned about. Okay, so let me actually put something in my bucket and I'll show you what the difference is. Okay, just give me a second. Okay, let me take some questions in the meantime. Harish has a question. Does it cost expensive if we select all edge locations compared to other options? Not really. There really isn't a difference in the cost. I mean, you could argue because more edge locations are used and you might get more hits on your on your origin, but otherwise it doesn't really matter, right? Because you're not charged for having used the locations. You're only charged for how much data is being transferred, right, through the edge locations. All right, so I've uploaded a few files onto my S3 bucket here. Now I will first show you that these buckets are indeed private. I'm sorry, these files are indeed private, because if I go into the file and if I try to open the URL here, you can see that I am trying to access the object directly from the bucket, but you can see it's not showing up, right? It's request denied. Sanchit, is there a delay in transmission from my end, or did you just bring up that question right now? Sanchit,
I
can you
think
hear me?
there was a delay at your end because I think I brought it up a few minutes back.
Okay. All right. So this is basically the file. As you can see, it's directly accessing from a bucket, but then obviously the access is denied. So here's what I'm going to do. I'm going to first, let me just enable the network tab because I want to show you the speed of the transfer. Okay. And here is the actual URL. So what I'm going to do here is I'm going to copy this. Just open a notepad. I'm going to paste that URL here. So this is that URL. So what I really need to do is just change this part of it. Okay, just give me a second, guys. I'm just refreshing. I think there's a little bit of too much latency. Let me just get back in here 1 second, guys. Yashasvi, am I audible? Yashasvi, yours. Sanchit, can you confirm if I'm audible?
Yes,
Yes, you
Sajid,
are.
go ahead.
Yeah, sorry, my system kind of hung up and I had to come back in. Just give me 1 second. Let me just log back in. Okay, my browser had crashed, so I had to reopen everything now. Where were we? Okay, I was showing you this part where I was saying that, as you can see, there is a file here, but obviously it's not accessible because I'm trying to access it directly from the S3 bucket. So what I'll do here is I'll just replace this part with the actual CloudFront URL, right? So I have the option to replace it either with the domain name based URL or with just the actual CloudFront distribution URL. So like I said, this is the CloudFront distribution URL, right? And obviously this is also the CNAME or the alternative URL. So I'm just going to use this alternative name. Remember, you can of course use this as well, but I'm choosing to use this because I've gave it that option. So what I'll do is I'll just replace this bit with the CloudFront distribution. So now it's going to go through the edge location and then hit the origin instead of trying to directly hit the origin, right? So I'll take this, and before I show this to you, let me just enable the network tab. And I want you to watch the speed of download because this bucket is actually in North Virginia. So let's see how fast it's able to get this file the first time. Okay. So as you can see, it's trying to. Okay. Oh yeah, I need to. What am I doing wrong here? I don't have to do this. It should show me. Let me try another file maybe. Okay, let me temporarily make it public. Okay, my browser is actually caching the result. Let me try a different browser. What am I doing wrong here? So the bucket policy has the CloudFront origin access identity, so that should allow it. 90C CF demo. Okay, let me just try maybe a different file for CF demo. Okay, I don't have to make this public, but I'm just trying to troubleshoot right now. Let me just see. There's something somewhere wrong. Oh, I see what's wrong. I actually have the URL twice. So I just need it once. I had the URL twice in there, which was absolutely not necessary. So if I try this now, okay, there we go. It's my mistake. I actually had that domain name in the URL twice. When you have to replace the URL, you have to ensure that the entire bucket URL gets replaced and not just s3.amazon.com. Okay, that was a mistake I made. Okay, so the image did actually load over here, and let me have a look over here. So if you have the network tab open under the developer settings in your browser, you can actually see this. So it took about 3.68 seconds for it to actually show me this file. So before I go in and check this, can you tell me if this was a hit or a miss in terms of CloudFront cache? Can anybody tell me if this was a hit or a miss? I will show that you in the actual header response, but I want you to make a guess. Was this actually a hit or a miss? I am talking with reference to the flow here. Okay, so let me show you that. This was actually a miss from CloudFront. So you can see here Xcache, it shows that it was a miss from CloudFront, which basically meant that when I tried to access this file via an edge location, the file was not there in the edge location, and it had to actually go and fetch the file from the origin and bring it back. So hence it is a miss from CloudFront. Now what I'm going to do is I'm going to refresh this, and I want you to keep an eye on both the timing as well as the hit or a miss, right? As you can see, it also shows me which is the pop location or the edge location that I hit, which is, as you can see here, HYD50C2, which basically kind of gives me the impression that I did hit an edge location in Hyderabad, because HYD Hyderabad. It took 3.68 seconds, so I'm going to refresh this. It should be there in CloudFront cache now. So refresh. As you can see, it was almost instantaneous. It went down from 3.98 seconds to 1.19 seconds, right? So that was what, 50%, more than 50%, or half of the time for downloading the same file. And if you now go and look at the cache, you can see it is a hit from CloudFront. So you can see here that it is a hit from CloudFront because of the fact that the last time I tried it, it didn't have it in the edge location. It had to go fetch from the origin, and origin meaning the S3 bucket, and it had to bring it to the edge location and then give it to me. So it was a miss. But when I'm accessing it the second time, it is already there at the edge location. So it is giving it to me directly from the cache. So it is a hit. And as you can see, obviously the time has also decreased very drastically, which is about 1.19 seconds, which is half the time. All right. If you have any questions, please do post it in the chat. I might not be able to take live questions from you because I think there is a delay of about 2 minutes between the time I ask something and the time I'm seeing the responses. So do post anything. I will try to respond as and when possible. So this is the basic function of CloudFront here. We saw that it also reduced the time in delivering the content. Also the fact that if I try to access the file directly, assuming that, let me just remove that public access that I had set. So as you can see, even though the file is private, I can still access it via CloudFront. But if I try to access it via S3 directly, it gives me an access denied. So this way I can control and make sure that anybody who needs access to this file can actually come through CloudFront. Now obviously this file is just as an example. This can be anything on a website as well, right? All of the images that are loading from your website can also be any of these images, right? I'm just accessing the image directly. We don't have the time for that kind of a demo today. Otherwise, I could have shown you a fully functional website where all of the images on the website are actually downloading from CloudFront. And most of the websites today that are making use of S3 buckets to store their images are actually doing it that way, where the website is loading, it's loading the page, and all of the images that are on the page are actually being pulled from CloudFront, which is basically stored in S3. Okay, so I hope this part is clear, and let us move on to the next topic. But if you're doing this, please make sure that you disable and delete any CloudFront distribution. There is no charge for keeping the distribution active, but if somebody tries to download something that you've uploaded there, it might cost you some bandwidth. So just be careful. Okay, let's move to the next topic, which is Global Accelerator. I will wait here for a quick 30 seconds to see if there are any questions from the previous topic, which is CloudFront. All right, no questions. Okay, Rohit, I think you missed the first part where I explained it. Origin access identity is nothing but it's, think of it like IAM user, where you're creating an identity and you're saying that only this identity can access the S3 bucket. Okay, and then you're associating that identity with the CloudFront distribution. So you're just creating an identity which is nothing but like a username, password, and then you're associating that with the CloudFront. And on the bucket policy, which I just showed you kind of 2 seconds ago, which I'll just quickly show you as well, which is if you go into the bucket and you look at permissions and you look at the bucket policy, you can see here that in the bucket policy, it is mentioned that only this origin access identity can access this bucket, right? And this origin access identity is actually connected with the CloudFront distribution. So basically that is just ensuring that only the CloudFront distribution can access this bucket or any objects in this bucket, basically. All right, let's move forward with Global Accelerator. So before I read out this and explain it to you, let's look at the scenario of what a global accelerator is basically used for. So let's talk about the same scenario that we talked about, which is you seem to have customers across the globe, but you have launched one location in terms of your hardware setup, and you're trying to use that location for the rest of the globe. So obviously customers that are close by can obviously get faster access, but any users that are across the globe that you have will have to traverse the internet through their regular lines, regular internet connections, and come to the actual region that you have, right? Of course, you can overcome some of this latency by making use of CloudFront, so that these users, instead of directly accessing that location, they will connect to their nearest edge location, and then via that edge location they will connect to the actual location or the origin, right? This is all well and good, but then this when you do your edge locations and you have a single region here, you might solve the problem of latency, but you're still not solving the problem of redundancy, which is, you know, having a second environment in case something fails, right? So in order to increase both your redundancy as well as lower your latency time, you decide to go ahead and create multiple regions and have users within those regions access that particular location, right? How do you make this possible? You use you make this possible by making use of Route 53, right? In Route 53, you will create this geolocation based routing, which we kind of mentioned in our last session, where you will say that everyone from India will only access the region in Singapore. Anybody from Australia will only be accessing this. You will create that kind of a link inside your DNS, so that anyone who comes to example.com will be given the IP address of each region depending on where they are coming from, right? If this is still confusing to you, please make sure you refer the previous session where we talked about Route 53, right? Now, the problem here with using this as Route 53, for example, let's say that each of the location has an IP address, right? This location has 1.2.3.4, this has 3.4.5.6, and this is 6.7.8.9. Now, if you use Route 53, anybody coming from India, okay, I have created an entry in Route 53 that they will always be given the IP address of AP Southeast 1 region. So the IP that they will be given back will be 6.7.8.9. Okay. Anybody coming from the US, when they try to come to example.com, Route 53 will return them the IP address of 1.2.3.4, and then they will connect to that IP address, right? Now, this is all well and good, but the problem arises when one of these regions go down, right? If one of these regions go down, what happens to all of those users who are trying to access that region? Now, within Route 53, you can, of course, set up something called a primary and secondary record, and you can do a failover routing. There is failover routing available within Route 53, right? So you can do a failover routing. But remember, we have always mentioned that within Route 53 as well, there is also TTL for records. So let's say that you created a record called example.com and you associated the IP 6.7.8.9 with that record. Then there is a TTL. There is a TTL of maybe 1 hour or something like that you've kept, which means this record will be cached in the user system for a certain period of time, right? Now, if this goes down, then obviously when the user tries to access his website again from that same region, he will again try to access that same IP, because that is what is there in his system cache, right? Unless he requeries again, and then Route 53 gives him the IP of one of the other regions because failover has happened. Unless that happens, the user might still see a blank page or might have an issue with the website, right? So although you have Route 53, although you have multiple regions, there is still this problem where sometimes redundancy doesn't fully work, which means it takes a minute or so for it to fully kick in, right? It's not instant. This is where the concept of global accelerator comes in, right? So what global accelerator gives you is, instead of you having multiple IPs across the globe, there are two anycast IPs that global accelerator will give you. If you look at this, these two IPs are the same across the globe, right? So this and this is the same, this is also the same, and obviously this and this is the same. So they will basically give you, when you use global accelerator, they'll basically give you two IPs that are anycast IPs. What that means is it's the same IP for all these regions that you have, and I believe you can have up to 10 regions set up like this. So in this case, regardless of where the user is coming from, whether the user is coming from India, whether the user is coming from Australia, whether the user is coming from US, they will always be returned only one of these IPs, right? Or either of the IPs, right? Which means you don't have to wait for a failover to take place, right? Because a global accelerator knows that if a particular region has failed, it will just start routing that connection to the other region without waiting for the IP failover to take place. There is no IP failover, there is no DNS failover happening over here. In Route 53, your IPs are all the same. Route 53 never looks at the system and then it sees a failure and then it switches the IP and then gives you another IP. You don't have to worry about the TTL or any of that. It will automatically just start switching and just working for you, right? So global accelerator is something that sits again at the edge location, where it is working in conjunction with the edge locations and also with Route 53 as well. And it is ensuring that you get uninterrupted fully redundant access across all of your regions that are there, so that you don't have to wait for a DNS failover to take place, etc. Now, because global accelerator is already at the edge locations, what that also means is that you get super fast access without having to connect through regular internet providers. It will take you to the nearest edge location, it will connect you from there, right? So with that said, let me come back to the screen. So it's a network layer service which is always sitting in front of your applications, basically at the edge location, right? Along with CloudFront, it'll give you two anycast IPs, and it'll obviously give you the lowest latency because you are making use of the edge locations. You can route the traffic to EC2 instances or ELBs. You also get kind of control in how to, like, you can fine tune the data transfer that is taking place. There is also inbuilt DDoS protection that you get. Now, how does this look? These are all of our edge locations that we talked about before. This is how you would normally set up with Route 53. In your Route 53 example.com, you will have two IPs, 1.2.3.4 and 3.4.5.6. 1.2 is here, 3.4 is here. And of course, Route 53 has the ability to fail over. If this fails, then it has the ability to stop giving this IP, and it will only give this IP. But remember, there is always that issue of TTL where users still might have the old IP with them, and they might still end up in the old environment, etc. So this is the problem that you have with Route 53. It's not a problem, it's just a DNS global issue that's always been existing. Now, if you were to use Global Accelerator, this is kind of how it looks, where you still have Route 53 sitting in front of Global Accelerator, but now you are using the Global Accelerator IPs instead of the instead of your regional ELB IPs or your system IPs, right? So there is no failover of IP happening here, right? Route 53 doesn't have to fail over or anything like that. Global Accelerator is anyways connected to these edge locations. And depending on which location you are coming from, so for example, if you're coming from, let's say, India, it knows the closest region to you is maybe something like Singapore or Mumbai if you have set up in Mumbai. But if you're coming from North America, maybe you are only set up in the North Virginia region, it will automatically redirect you to the North Virginia region. Okay. You can, of course, control the traffic that is going in there. This 100% here and this 100% here basically means that you're willing to take all 100% of the traffic that is destined to be sent to that region. Okay, so this does not mean you're splitting traffic 50-50. That's not the case here. You're just saying that it is willing to take 100% of the traffic that is coming into that region. Otherwise, it'll start sending some of the traffic the other way. Now, within the region also, you can set some balancing. Okay, for example, you can say that 50% of traffic goes to one load balancer and 50% of traffic goes to another load balancer within the same region. If you wish to, you can also fine grain or control it like that as well. But all of this said, you have all of this controls, you have all of this, dials that you can move around and all of that. That's not the main concern here. The main concern here is that now you have the ability to send users to their closest location without you having to worry about managing Route 53 records and failing them over and health check and all of that. You don't have to worry about that any longer. Global Accelerator will completely take care of that for you. Now, let me quickly show you a setup that I've already done for this, because even setting up the Global Accelerator does take some time, but I'll show you if you have to do it, how do you set it up. Now, what I'll also show you is, let me show you the EC2 instances that I have running in the two different regions. So you can see here, this is the North Virginia region. I hope this is clear. So this is the Mumbai region, and this is the North Virginia region. So in the North Virginia region, I have a system called shop2, and here is the IP address of that. So if I take this IP address and if I put it in the browser, you can see I have a site there, and this site basically tells me that this is the application on the North Virginia server, and this is the private IP address of the server. If you see 31.23.46, um, 31.23.46, right? And this is in North Virginia region. Okay. Now, if I also go to the Mumbai region, I have another instance here, which is similar to shop 2. I have shop 1 here. And if I take this IP address, I just name them as shop. Okay, there's no significance to that. And if I just load that over here, you can see that this is the application on the Mumbai server. So essentially what I have is I have 2 regions that I'm using. I have 2 regions that I'm using. One is the US East 1, and one is the AP South. AP South 1, which is basically the Mumbai region. So I have an EC2 setup over here. I also have an EC2 setup over here, right? Now, obviously, if I want, I can go into Route 53 and I can configure certain records where I say that users from a particular region go here, or users from another particular region go here. I can do that in geolocation based routing, but I'm not going to do that. Instead, what I'm going to do is I'm going to enable global accelerator, right? I'm going to enable global accelerator, and I'm going to connect both these endpoints to global accelerator. Okay. And in Route 53, I am just going to configure a record. For example, let's say portal.aws-training.in. Okay, I'm going to configure a record in Route 53, which basically says that any queries coming to this, you send it to the IP addresses of the global accelerator. That's essentially what I'm going to do here. Okay, so I have 2 instances in both the regions. Instead of mapping each of those individually in Route 53, I'm going to create a global accelerator. I'm going to map both those instances to the global accelerator, and then Route 53, I'm just going to create a record which sends it to the global accelerator IP. So let me show you those. These are the 2 instances. Okay, Mumbai region and North Virginia region. Now what I'm going to do is I'm going to go to global accelerator. I will say create accelerator. I will give it a name. Okay, I will just go with the standard routing, and I will go next. And here I will specify what are the port numbers that I need for the accelerator. So I'll say port 80, port 443, or whatever, maybe another port like port 22 or whatever, right? And I'll say it is a TCP protocol. Client affinity is if I want like a user to be mapped only to one instance once he gets connected, right? This ensures that their session activity is stable. This is useful if you want to stick a user to a particular system for whatever reason. Okay, but I'm not doing that. I just want the routing just to take place. I don't care about whether the user goes to system 1, system 2, system 3, whatever. So that's the port numbers. Next, here I have to select the regions that I want this global accelerator to serve. So I will select US East 1. I will also select another endpoint group, which is again AP South 1, right? And I want both those regions to take 100% of the traffic, right? So I want both of them to accept all of the traffic. So there you have it. US East 1 takes 100%. AP South 1 also takes 100%. Now, if you want, you can ensure that you configure some health checks here just to make sure that it can fail over properly. Okay. And okay, that's just selecting the regions. Once you select the regions, you have to select the endpoints within those regions, which basically means the EC2s within those regions, right? So here under US East 1, I will add endpoint, and I will say my endpoint is EC2 instance. As you can see, you can select network load balancer, application load balancer, IP address, etc. I will select EC2 instance, and I will say my shop 2 in the North Virginia, right? And the other point, I will add endpoint, and I will say EC2 instance. This is an AP South 1, which is Mumbai. And I will select my Mumbai server, right? And both of this, I will take full load, 255. Here it is not 0 to 100, it is 0 to 255. So I'll give it full 255 load because there is only one instance. I want that instance to take full load. So what I've done here is I have selected both the regions that I need, and then within those regions, I have selected the instances that I need. Then all you really need to do is click on create accelerator. It is that simple. It is just basically 3 steps. You select the ports, you select the regions, and you select the resources from those regions. Okay, and then just click on create accelerator. Now I've already done this because this takes about 30 minutes to get configured. So if I refresh this, right now you can see I've already created the same type of accelerator, and these are the two IPs that I have got as Anycast IPs, right? Now here is the DNS name for the global accelerator. Now, obviously, I don't want my website to be accessed by some random global accelerator name. So what I will do is I will go to Route 53. Of course, you can use this. If I open this right now, you can see it does go to my website, right? It does go to my website, and because I am in Hyderabad, the closest region is Mumbai, so that's why it is showing me the Mumbai server, right? But I don't want this. I want like a proper domain name, right? So what I'll do is I'll go to Route 53, I'll go to hosted zones, I will go to my domain name, and then I will create a record, and I will say portal.aws-training.in. This can be anything. I'm just selecting portal.aws, and I will select alias. I will select global accelerator, and I will have my global accelerator in the list. And then all I need to do is create a record. I've already done this, so I'm not repeating it again, but that's pretty much it. Now, if I do that, and if I go to portal.aws-training.in, you see it is taking me to my website. And this is because I am in India, it's taking me to the Mumbai server. Now, no matter how many times I refresh this, this will 100% almost always take me to the Mumbai server because that is the closest one to me, right? Now, I do want to show you that I am using another browser where my location currently is, I believe, Vienna. Let me just refresh this. Okay, I think I'm in the US. I'm using like a Tor network, which basically I'm somewhere else in the world. Okay, so right now I am in the US, and if I refresh this now, there you go. It's taking me to the North Virginia server because I am accessing it from a different region. Let me just refresh this and see if I can get a different. Yeah, it'll stick me to this for a little bit longer. So as you can see here, I'm accessing it from a different region, and it is in fact giving me the North Virginia region. Now you want to see the failover taking place. I will just go ahead and do one thing here. I will just temporarily stop my instance in Mumbai region. Okay. Now, before I do this, I do want to ask you this question. What happens when I stop this Mumbai instance here? What am I going to see when I try opening the website from my location here in Hyderabad? Will I get the North Virginia server site, or will I get a blank page? Just put your answers in the chat if you can. Just let me know what will I get if I stop this instance. So I'm going to stop this instance temporarily. I have stopped the Mumbai instance, which means if I now go to this, this is the Mumbai server IP, right? So if I refresh this now, obviously it's not reachable. Now it's not going to work. But then if I refresh this portal.aws-training.in, if I refresh this page, will I get a blank page, or a page cannot be displayed, or will I get something else? Please put your answers in the chat. I'm waiting. Okay, there's a question from Komaraju Shashidhar. Cloudfront comes with free tier for training. In fact, Cloudfront has 1 terabyte of free outbound data transfer for life, regardless of whether it is your free account or not. So you can definitely make use of that for learning. Okay. I'm not sure if it's a delay or something else, but I don't see any responses yet. So I will go ahead and refresh this page right now, and let's see what happens. So I am doing this from Hyderabad, so I'm not on a VPN or anything like that. I am in Hyderabad right now, and I'm going to refresh this page under portal.aws-training.in. Let's see what happens. Okay, it's not failed over yet. Let me see what Global Accelerator is saying, whether it's actually failed for the Global Accelerator or not. Yeah, so there is one unhealthy help point endpoint for the Global Accelerator. So there you go. It is redirected me to the North Virginia server. So I didn't have to change any DNS records. I didn't have to do any DNS failovers. It was all handled automatically by Global Accelerator. It redirected me automatically to the North Virginia server because it detected a failure of the instance. So as you can see in Global Accelerator over here, it showed that there was one unhealthy endpoint, which basically means that one of those instances wasn't working. And as you can see in AP South 1, unhealthy status for that instance. And obviously it took a minute to realize that, but yeah, it at the end of the day redirected me. So that is essentially what Global Accelerator is. Any questions before I move to the last topic for today? Okay, so I'm going to move forward because yeah, the latency is unbearable. It's almost 5 minutes now, so I'm going to move forward with the next topic, which is, let's talk about our last topic for today, which is DMS or database migration service. Now, there are many ways you can migrate your databases from one location to the other, depending on the database that you're using. Uh, many options, right? You can just take a whole image of your database and then move it. You can take a backup and then manually install that backup, etc. There's so many ways you can do it. But AWS basically provides you a service called as DMS or database migration service, which lets you select your source database and select your destination database, and then it'll automatically move your data from the source to the destination for you, right? This supports both homogeneous and heterogeneous transfers, which basically means you can do like to like, for example, MySQL to MySQL, all right? Or if you wish, you can go from SQL to Aurora or Oracle to Aurora, etc. You can also do heterogeneous migrations, right? The whole point with this is that you can actually do this without any impact to your existing databases, as in without any, like, you can continue using your applications and your database, and this would kind of do it automatically in the background. There are many additional features that come with this. It also ensures that once the migration takes place, it has the ability to continue to replicate the data even after the migration has taken place, right? So it's not just for migrating, but you can continue to replicate the data after you have migrated it. Okay, let's take an example over here. DMS or database migration service. You have two different locations. One is your on-premises and one is AWS. We are taking an example where you want to migrate your data from AWS, from on-premises into AWS. Okay, let's assume that you have your database inside your on-prem and you want that moved into AWS. Now, of course, this is assuming that you have already a site-to-site VPN connection established between both of the locations, which ensures that you can privately transfer data. But of course, there are other ways like direct connection as well, if you wish to establish that. Now, there are certain steps that you have to follow when you do the DMS migration. The first step is starting something called a replication instance. It is the job of this instance to actually connect to the source, connect to the destination, and then actually do the transfer. Okay, so it's an instance that actually does this for you. So here under DMS, we will start our replication instance over here. And then what you will do is you will connect both the source and the target. So you will create source and target endpoints and you will connect them. Okay, so you will connect your source and your target. Your source is on the left side, your target is on the right side. This is assuming we are transferring it to Aurora. Then finally, you will select the tables and databases that you need to transfer. And once you do that, AWS will start loading the data and try to keep it in sync for you. Now, I want you to watch here on the right side. Once the DMS starts, you can see that the data is slowly loading here on the right side. So once that connection starts, it will slowly start loading the data here. And once the data is completely loaded up to 100%, and the migration is done, but then it's not just that. You can continue to keep it replicating. You can continue to keep it moving your data from your on-prem to Aurora while you're still continuing to use your existing on-prem database. Now, once all of this is done, it's completely up to you when you want to make the switch, because remember, you can continue to use the on-prem because it is actually replicating in the backend. But then when you decide, you can just go ahead and switch the endpoints for the users, where you can switch the application from your on-prem to your existing database, to your newly moved database on Aurora. Any questions on this? All right. So I'm going to do a quick demo over here for the DMS. Let me first show you the application that I'm trying to transfer. So I have an instance here. This instance contains an application, or basically an application called WordPress application, which this instance right now has both the application and the database in it. Okay, so I'm going to show you a scenario where I'm migrating my database from an instance into RDS or Aurora, right? So I'm moving it from my instance into RDS. This instance currently is running a MySQL or a MariaDB database per se. Okay, so I want to move that into Aurora and use it in Aurora. Now, what I'm going to do is, let me first show you the site. So this is a site that is running on that particular EC2 instance, kind of like a news website or whatever, right? So you have some content over here, and all of this content is basically in the database itself. And I will show you that by showing you the database here. So let me just pull up this instance, 85.96. Yeah, so let me connect to this database. As you can see here, this is my current EC2 instance server, and there is this database called WordPress. And let me show you this. There are some posts in it, and if I show you the data, you can see that these are all of the posts that are actually created here, right? Where is the website? Yep, over here. So if you see here, there is this post called Top 5 Most Underrated Players in Premier League. I will show you that this is actually in the database if I can find it. Yeah, here it is. So you can see here it's in the database. I want to show you that this is actually, so you see this is on the EC2 instance, right? Because I connected to the EC2 instance IP, but I'm going to modify this right now. I'm going to open this and I'm going to modify this top 5 to top 6. Okay. So I'm going to modify this and I'm going to apply the changes. So I'm directly modifying the database. I'm doing this in order to, let me just make this a little bit more bigger. So for those of you who couldn't see before, what I've essentially done is I've modified the top 5 to top 6. Okay, I've modified directly in the database. So now if I come here and refresh this, you see here it went from top 5 to top 6. So I'm just showing you that I was modifying the actual database. Okay, now that database is on the instance itself. I can confirm this by showing you the actual instance. If I were to connect to this instance, so this is the configuration file for this application, and I'm going to open this configuration file to show you that it's actually connecting to the local instance, right? So vi.php. So over here, if I go down here, oh, I'm already down. If I go up, if you look at this database host, you can see that it's currently, okay, it's a little jumbled here, but essentially it's saying that it is localhost. All right, so the database is currently localhost, which means it is on the instance itself. Okay, what I want to do is I want to essentially move this from the instance into Aurora. So to speed up things a little bit, I have already started an Aurora database, which is basically empty. So you can see here there is already an Aurora database that's created here. If I go in there, I will take this and I'll try to connect to it. So if I go in here and if I try to connect, so here is that database 1.cluster. Just look at this last name here, which is 8G, KG8V, which should be matching with, yep, KG8V, right? So I'm just confirming to you that this is in fact the Aurora database. So I'm going to log into that database as well. And as you can see here, this is the Aurora database, and there is no WordPress database itself over there, right? As you can see, there is no, that database does not exist on this server right now on Aurora, right? So the whole idea is I want to move this database from here. I want to move it to Aurora using DMS. And then once that is moved, I will go to the application configuration and I will switch over the configuration file so that it starts working from Aurora. So what do? I open up the DMS service. I apologize, it's going a little bit above time, but I think we'll be done in another 15 minutes. So we'll go into DMS, and the first thing we want to do is obviously create the replication instance. So we can create a replication instance, give it a name, whatever you want to give it, and the instance type for the replication instance. Just select some basic things like your storage, the VPC, whether you want a multi-AZ replication instance, etc. Right? Once you're done with all of that, you can just hit create. Now, to save time, I've already created this. So as you can see here, there is already a DB DMS.t3.small instance, which is in the AP South 1 region, which is basically Mumbai. And I've named it Bootcamp 1. And this is my replication instance. So apart from the replication instance, now that it's created, I've created this replication instance, which is step 1. Step 2 is connecting the source and the targets, which basically means you have to create the endpoints. Now, I have already created the endpoints here, but I will just show it to you if you have to create it. Click on create endpoint, and you have to show whether you are actually creating a source endpoint or a target or a destination endpoint. Source endpoint will be the EC2 in this case. So I'll select source endpoint, and I can give it a name like EC2, and I will select the engine, for example, MariaDB, which is what I'm running. And I can say access it manually. If you have already stored your information in secrets manager for the database, you can use that. But server name, essentially you have to put in the IP address of your EC2 instance. It's recommended you put in your private IP here so that it can connect properly. And then you put in the port number, which is 3306, and you put in the username and password of the database, right? Of the database that's there on your EC2, and just create the endpoint. There are some additional options here. If you wish to, you can use that. You can of course test the endpoint as well once it's created. So once an endpoint is created, you can go to connections and you can test it to make sure that it is actually able to connect before you even begin the task of migration. So create your replication instance and then create your endpoints. For the destination endpoint, same thing. Create endpoint, target endpoint. And in this case, my target is an RDS instance, or basically Aurora. So I can just select RDS DB. I can select the RDS Aurora instance. And then I can just put in the same information like I've done before, which is the username, password, etc. So once you have both your both your endpoints created, which is your source and your destination, you can now go ahead and set up your tasks for your migration. So I will use database migration. Okay, Mohammed has a question here. Any require for agent in for on-prem for DMS? No, not required, because like you saw here, when I created the endpoint, and when you do source endpoint, as long as the information that you're putting here, for example, hold on, where is that? I put in EC2, or I put in like on-prem SQL1, okay, as an example, and then I select maybe SQL. Now here, it will ask you for the ID of the server, which basically means the IP address of your instance in your data center or in your on-prem, right? Now, like I said, this is assuming that you have already set up this site-to-site VPN or a direct connect connection, which means your DMS should be able to see the instances inside your data center without the need of any additional agent, right? And port number, and then the username, database name, etc., which basically means as long as it's able to connect to that, you don't need any additional agents for that. Okay, so once the endpoints are configured, let's create the migration task. Let's create task. Call this a demo. So first I'll select the replication instance which we have created. I will select the source endpoint. I will select the destination endpoint. I will say migrate existing data, or migrate existing data and replicate the ongoing changes. So this will be like a continuous process, which I don't want to do right now. I'm just migrating the existing data, which basically means I just want to move all of my database over. You can go wizard mode or do JSON setting if you want to like go very specific with your tasks. Right now it's saying that on the target, if your database is already created, for example, in my case it is not created. As you can see here, there is no database called WordPress over here, but there is WordPress on my EC2 instance, right? So if there was a copy of WordPress here or another database called WordPress here, I could choose this option which says drop that table, drop all of the tables on the target for that, and then kind of replicate it. But I'm just going to leave it at the default here. There are some additional options here. Just leave them at the default for now. If you're a database person, you would know most of these, but for now I'm just going to ask you to leave it at the default one. You can enable validations if you wish to. CloudWatch logs also optional. Additional if you want to create specific schemas that you want to target, or if you have a table that mentions all of those schemas, you could do that. But again, I'm just moving it as it is. I'm not modifying my database. Remember, there are heterogeneous migrations which you can do as well, but I'm just doing like a homogeneous, like to like. I'm doing MySQL to MySQL right now. Okay. Okay. I am going to start migration task automatically. I'm not doing any pre-migration assessment. I am not doing any additional selection rules. I think I'll just leave this one here, which is all of my schema. Hold on, I'm not using this. And I will go create a task. Okay, I need to create at least one selection rule here. I will say all of the table names include okay. I haven't created a schema from this, so what I'll do is I'll just do a star here. Sorry, percentage, which basically means all. So all of the schemas, all of the tables, create a task, and it's creating that task, and we'll just wait for it to complete. And as you see it completing, essentially what I'm supposed to see is I'm supposed to see that the WordPress, I'm not sure if you can see this or if it's big enough, but I'm essentially supposed to see this database WordPress migrate over here. Not migrate, but get added over here. So it's still be there in the EC2, but then it'll also be here in Aurora. Any questions in the meantime? Aurora is, so Mohammed has a question, is creating Aurora in free tier or will it be cost? So Aurora itself is not free, but you have the option of trying this with your RDS databases, where you do get one free RDS instance, which you can try. So I believe as long as it is a db.t2.micro, you should be able to run an RDS instance without issues. Without additional cost, that is. But remember, the DMS, you have to run a replication instance, and that replication instance is not free. So keep that in mind. Okay, so that is starting. There you go. You can see here WordPress database. It has now come over under Aurora. But let's wait for it to finish. It has some errors, but that's fine because I didn't fully customize it. But I think I got most of what I need, especially under posts. Yeah. Okay, so I think everything has been migrated over to Aurora, but here's what I'm going to show you right now. I'm actually going to modify the data in my Aurora database and actually show you that it's not going to change on my website yet, because my website is still using the instance database. Okay, so as you can see, I'm refreshing here. It still says top 6. Okay, and I am going to edit this. I am editing this in the Aurora database. Okay, it's not on my EC2 database. I'm going to edit that and I'm going to apply that. So that's applied in the database. But if I refresh here, as you can see, it still says top 6 because it is still using the instance database. Okay, so I'm going to modify my application to start using the database from Aurora, right? So to do that, let me just first go ahead and copy the Aurora database reader, or I'll just copy the writer as well. So I'll copy this, the Aurora DB link, and I will come here. Okay, the other one is still open. Okay, here's what I'm going to do. I'm going to change this DB host, this one right here. I'm going to change this DB host from localhost. I'm going to delete that. And I'm putting in the Aurora database here. So it'll try to reach the Aurora database with that information. But of course, there is something else also that I have to change, which is basically I need to change the username password because it's not the same as the one I have here on my instance. So I'll change that to admin. And this will be changed. Okay, so I've updated the database user and password as well as the host name for Aurora. The DB name remains the same because it's the same DB name. Enter. Okay, it's saying it's written. Let me just verify that it's actually written. Okay, it has actually written that file. So now if I go ahead and refresh my application, you should still see the same thing because it should load from the Aurora database. But remember, in the Aurora database, I had modified this top 6 to top 7. So if this shows top 7, it means that my database has been fully migrated and that it has been successful. So I'm going to refresh. I am myself not sure if this is going to work. So let's see if this is going to work. Okay. So refresh. And there you go. Top 7. And it's exactly as it is. So you can see the site is exactly as it is because all of the data that was supposed to be in the instance has migrated successfully over to the Aurora database. As you can see, top 7. And in fact, let me just show you once again. This is the Aurora database, and I'm going to the Aurora database WordPress WP posts data, and I'm changing this to top 8 date. And if I refresh, there you go, top 8. So you see that it's actually loading from Aurora. So I hope this has been helpful for you. Any questions on DMS? Abhijit, you would not require any additional agents. Just like you saw, as long as you can add the endpoints, you should be good. All right, with that, I would like to wrap up today's session as well as the sessions for this entire weekend. And before we go, I would like to quickly once again thank all of the other bootcamp organizers as well. And if Yashasvi or Sanchit could come back on here and just
Yeah.
give the closing comments.
Yeah, okay. So, as we come to the end of this insightful session, I would really like to thank Faisal Khan, who spared his precious time for us and delivered such an informative session on Cloudfront, Global Accelerator, and data migration. I'm sure all the participants really enjoyed and learned a lot from this session. I'm certain that the knowledge imparted in this session will help them advance and avail greater opportunities in their career. I would also like to thank all the participants who gathered here to learn. Your presence made the session successful. Thank you. Thank you so much, Faisal. Hello, am I audible?
Yashasvi, please make sure you hit the end broadcast button on the top right.
Yeah, yeah, yeah. Okay. Thank you, everyone.